Problem 84. Phenylephrine, C9H13NO2, is the decongestant in Sudafed, PE. Phenylephrine replaced the decongestant pseudoephedrine, which was readily converted to the illegal stimulant methamphetamine. I'm sorry. Fill in all lone pairs and double bonds to give every atom its usual bonding pattern. So here is the molecule. I've copied it over here, and we're supposed to basically finish the Lewis structure. We're missing some double bonds, and we're missing some lone pairs. And so let's do that. Now, to do that, we need to know what the common bonding patterns are. And so hydrogen, with its one valence electron, likes to form one bond. And it looks like all of the hydrogens have their one bond. So all of the hydrogens are good. The carbons, on the other hand, have four valence electrons. They like to form four bonds. Now this can be maybe four singles, or two singles and a double, or maybe a single and a triple, or two doubles. Anyway, when you're looking at the carbons, some of them are good. This carbon has 1, 2, 3, 4 bonds, so this is done. This 1, 2, 3, 4 bonds. This carbon is also done. This carbon is also done, but several of the carbons have 3 bonds. And so like looking at any one of them, you see 3 single, 3 bonds. So there's no other atom to attach the 4th single bond. So it looks like this is going to be 2 singles and a double somewhere. So the hydrogen has to be a single. So pick one of the other ones. Say this is a single, then the one going up to the top right is a double. And doing that kind of fixes this carbon. It now has its 2 singles and a double. But now we got to fix this one. Okay, we know this is a single and this is a single now, and so that has to be the double. Okay, and then this carbon is good. Now this one, this is a single because we already fixed it. This is a single, and so that has to be the double. And now we have added double bonds alternating all the way around. Now there was one other way we could have done that. So let me copy this and let's paste it down here. One other way we could have done that. It kind of depends on how you start. Okay. We could have done it like this. Put them there, there, and there. So you see how, instead of here, here, and here, the double bonds are there, there, and there. And that would also work. Okay. Now you can take either one of these and then finish it. You still have to do the oxygens and the nitrogens. They need lone pairs. So all of the carbons and hydrogens are finished now. So we'll check those off. Check, check. Now what about the oxygens? The oxygens, 6 valence electrons, so they need 2 bonds and 2 lone pairs. Okay, so looking at the oxygens, this one has its 2 bonds, so let's give it the 2 lone pairs. 1, 2. And then over here, it's got the 2 bonds already, so 2 lone pairs. 1, 2, and that's it. So no more oxygens. Oxygens are good. Let's do the nitrogens. Nitrogen has 3 bonds and 1 lone pair. And here it is. I see the 3 bonds, so let's give it the 1 lone pair. And then after you do that, the molecule is done. Now I will go ahead and convert this to the skeletal structure. Let me get rid of this other one. We don't need that anymore. So let's take this molecule and let's convert it to its skeletal form, even though we weren't asked to do that. So we got, so here, 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 and this is OH. And then here we got 1, 2 carbons, and then the nitrogen, and H, and then 3. Okay, you see that? You see that? Oh, we're missing the OH here. Forgot about that one. Oh, I'm glad I caught that. But I got a bunch of emails if I didn't catch that. So OH. And there we go. Check.